In a previous video, we found the expression log base 10 of y hat, which of course means the predicted values for the log of y can be found by this expression 0.0215 plus 0.3193x. Now the problem with this would be that when we plug in values for x to make a prediction, what we would get back would be the log value of y. Well, in order for this model to be optimally useful, we would really want y values to come back, not log values of y. So let's take a moment and think about how logs work. So let's say we have log base 10 of y equal to some linear expression like we have here, a plus bx. We remember that this could be rewritten in its exponent form as y equals 10 raised to the a plus bx. And then we think for a minute about when is it that we add exponents, and that occurs when we multiply with like bases. And so we'll rewrite this as y equals 10 raised to the a times 10 raised to the bx. And then we think again about, well, we've got some exponents that are being multiplied here, and when do we do that? And the answer to that is when we raise a power to a power. So we have 10 raised to the a times 10 raised to the b, and then that particular expression then would be raised to the x value. So what we could do then is say, well, let's just have some c value and say that that'll be equal to 10 to the a, and then we'll have some d value, and we'll say, well, that'll be 10 raised to the b, and then we wind up with the expression y equals c times d raised to the x, which will be our exponential function form for our regression model. So let's go through that process with this model. So we will now write this as y hat equals 10 raised to the 0.0215 plus 0.3193x, which would be the same as y hat equals 10 raised to the 0.0215 times 10 raised to the 0.3193x. And again, y hat equals 10 raised to the 0.0215 times 10 raised to the 0.3193 raised to the x. And a quick calculation will tell us that 10 raised to the 0.0215 would be approximately 1.0508, and 10 raised to the 0.3193 would be approximately 2.0859. So now this model we can express as y hat equals 1.0508 times 2.0859 raised to the x. And again, the benefit of this is that we are able to make predictions by plugging in hypothetical values for x and then getting back from that a predicted value for y.